Okay, good afternoon, everyone. My name's Bryan Sims. I'm with the University of Texas at Arlington. Okay, what we're going to do today is we're going to go over what asbestos is, where it comes from, a little bit about the health effects associated with long-term exposure to asbestos and asbestos-containing materials, a little bit about the rules and regulations that are in place, federal and state rules in place for the management of asbestos-containing materials in buildings. And then we're going to talk a little bit about policies and procedures that should be in place in any facility such as your own. Let me first start by asking, somebody tell me what asbestos is. Class interaction here. What is asbestos? A mineral. It's a rock. Okay? It's a mineral, but it's a very unique mineral, one of the most unique minerals on the earth. It has four very unique characteristics to that particular mineral. Can anybody tell me what those characteristics might be? What makes asbestos unique? Come on, help me out.
It's always breaking the same shape.
Okay. First, let's start with its strength. It's very strong. It's one of the strongest rocks on the earth, much stronger than granite, much stronger than quartz, dolomite, gypsum, the other minerals that we find on our earth. Because of that, we used it in things such as floor tile, VCT, VAT. Does anybody know what those terms are? What is VAT? Vinyl asbestos tile. And it has asbestos in it. What is VCT? Vinyl composition tile. What's the difference between the two? One has asbestos, the other has quartz and other silicates in it. VCT, the new 12 by 12 VCT tiles we put down, they'll last 10, 15, 20 years maybe. The old 9 by 9 VAT tiles that you see in schools, they last 30 or 40 years before they wear down, simply because this rock's harder than this rock. Asbestos is a much harder mineral than quartz or the other silicates that are in VCTs today, limestone specifically. So it's a very strong mineral. Let's talk about the second characteristic that makes it unique. Make any guesses?
Heat resistance?
There you go. Thermal resistance. Heat and cold. It's a very thermal resistant rock. Basically, this rock doesn't get hot. It doesn't get cold very easily. That's because of how the chemicals that are used to compose that rock or make that rock in the earth and how it's made in the earth. It takes temperatures in excess of 2,000 degrees Fahrenheit before you start affecting the rock, that particular mineral and the composition of that mineral. Because of that, we used it for two applications in construction. We used it to hold heat in and to hold heat out. What would be an application where we'd want to hold heat in? Insulation, pipe insulation, boilers would be a good example. Boilers and steam lines. We want to hold that intense heat onto a boiler or a steam line, so we wrap it with material that basically doesn't get hot very easily. What would be an application where we would want to hold heat out?
Refrigeration.
Okay, we'll talk about brake pads in a minute. What was the other one?
Refrigeration.
Refrigeration could be possible, but one I'm looking for is fireproofing. I was looking for fireproofing, or an application where we would want to hold heat out. Well, let's talk about fireproofing a little bit, because this is really what brought asbestos into the United States and blew it into a multi-million-dollar industry. Back at the turn of the last century, we started building buildings in the United States, mainly in the Northeast and the West Coast, that were superstructures. Okay, high-rise buildings, 100 floors plus. Congress went back to the construction industry and said, if you're going to build 100-floor buildings, you need to find a way to protect them from fire. Fire was the big issue at hand at that point in time. So what they did is they went back in and industry just started building these buildings again, and as they did, they would build that same steel superstructure, and they would spray before they poured any of that lightweight concrete in place. They had a big piece of steel there. They would spray the entire building with asbestos, coat it with about a 1/4 inch to a 1/2 inch coating, a spray applied fireproofing. So now they would cover the entire building with it. We get a fire on that 30th floor, and that fire is burning right here. There's plenty of time for people to get out of that building before that steel superstructure starts to heat up, because it's coated now with a fireproofing material that needs temperatures in excess of 2,000 degrees to really start affecting that too much. So that was very, very effective, worked very well, and many, many buildings in our country had spray-applied fireproofing throughout the buildings. Any questions over its thermal resistance? Very important aspect of asbestos. Okay, the third characteristic, and Paul, you touched on it just a few minutes ago, one of the applications for it. Asbestos is very friction resistant. Much like its strength, basically this rock doesn't wear down very easy. For that reason, we used it in things like brake shoes, clutch assemblies of heavy equipment cars. Still using brake shoes and clutch assemblies across the country, across the world today, especially in heavy equipment. If we put asbestos in brake shoes of your cars, they last 30,000 miles. We put quartz in the brake shoes of your cars, they'll last 5,000 miles. This rock's simply harder than this rock. So because of that, it's friction resistant. We used it in a lot of assemblies, brake assemblies and clutch assemblies. Okay, any questions over these characteristics of asbestos? Strong, thermal resistance, friction resistant. Okay, now let's talk about the other. Somebody hit on that a few minutes ago, shape. That's the issue. The morphology or the shape of this rock makes it very, very unique. Let's talk about rocks for a few minutes. Asbestos is one of the few rocks on the earth that is considered fibrous. And to be fibrous, it has to meet the definition of at least 3 times longer than its width. And not exactly, at least 3 times longer than its width. So that marker is fibrous by definition. That eraser would be fibrous by definition. There's 6 types of asbestos on the earth. 5 of them look like that, and 1 of them looks like that. Take it a little bit farther. Talk about why that might be a problem for us. Basically, there's 3 types, or for the most part, there's many different types of rocks and on the earth, and minerals on the earth. For the most part, you can throw them into about 3 different categories. You have rocks that would be granular in shape, round for the most part. And that would be something like, let's take quartz, is a good example. Then you'll have materials that are plate-like, micas, and gypsum would be a good example. Those are rocks that like peel apart in a plate. They'll come apart with plate-like. And then you have fibrous, such as asbestos. So those are 3 very unique different shapes of minerals. Okay, let's talk about why that can be a problem for us. Okay, how many folks remember the 3 diseases associated with asbestos exposure? Anybody remember one? Asbestosis, that's good. Mesothelioma, lung cancer, and lung cancer. Let's talk about the 3 real quick. And actually, asbestosis is not a disease. It's a scarring in the lung tissue, but it's classified as a disease when it comes to asbestos exposure. Let's visit about that real quick. Now, I'm not a good artist, so you guys don't make fun of me. That's a set of lungs. Here's your windpipe. You breathe in, and you inhale, and then, of course, when you exhale, you breathe air out. Talking about asbestosis, asbestosis is truly a dose-response. There's a dose-response relationship to asbestosis. The more dose you put in your body, the higher chance of a response you're going to get. So it's about large quantities entering into your lungs. 2 ways to be exposed to asbestos. You got to breathe it or eat it. Inhalation or ingestion. Won't come through your eyes, won't come through your ears, won't come through your skin. You have to breathe it or eat it. And those are two pathways. We're not worried about you eating building materials, typically. I've got a few folks on my campus that might, but it's for inhalation that's the issue that we're concerned about. When we breathe in construction, we breathe a lot of different materials in. We breathe fiberglass, mineral wool, synthetic fibers, Dacron, rayon from carpets, cellulose fibers. We breathe in pollens and molds and things of that nature into our body. When we talk about asbestos, I'm going to run a scenario real quick for you where we're going to cut a hole in the wall. Okay, we're going to cut a hole, 3.0 door in that, 3.070 over here, 3.070 over here, through drywall. Okay, what's our means of cutting a hole in drywall? How do we do it? Pop a line and break out what? What's your tool? Sawzall, reciprocal saw. What happens when you hit drywall with sawzall? Snows. in your face immediately as soon as you hit it, it's snowing. Now let's say in that process we're going to breathe, let's say this wall does not contain asbestos, okay? What is drywall made out of? Gypsum. So we got gypsum over here. We know what that looks like. It's a little mica, plate-like material. We're going to breathe 80,000 gypsum particles, okay? 80,000 particles come into our lungs. We breathe those particles. What are they going to do? Bounce around. When you exhale, they're going to come out. Okay, the vast majority of those particles are going to come out of your lungs. You're not going to like it. You're going to cough. Bad things are going to. You're going to feel like bad things are going to happening to you, but you're okay. They're going to come out for the most part. Normal set of lungs, by the way. Okay, now let's cut a hole in this wall over here. Same thing, but this time we've got 5% cryostyle asbestos texture. Okay. We break out the Sawzall. It's snowing in our face. Now what are we breathing? What do you think they're going to do? They're going to act like 80,000 little darts, 80,000 little harpoons, and they're going to stick. Not all of them. Maybe 274 stick out of 80,000. Okay, why do they stick in the lungs? Simply their shape. Best analogy I can give you is a dartboard. You put a dartboard on the wall, you throw a baseball at it, it bounces off. You throw a dart at it, it sticks. It's simply the shape of the mineral you're putting in your lungs, and that's all there is to it. Asbestos is not toxic. It is simply a mineral that is shaped uniquely in a fashion to where it can stick in your body pretty easily when you're breathing in. Now what happens is when it cuts you, or when it goes in your body and sticks, it cuts you. You don't feel it. These are microscopic fibers. When it cuts you, it creates scar tissue. When you get cut on the exterior of your body, you get a scar. When you get cut on the interior of your body, you get a scar. That scar tissue over a long period of time is not as elastic as your regular skin is. So as you start to breathe, what happens over a long period of time of exposure, you're 20 years old, your lungs are about like this when you breathe in and out. After 10 years of asbestos exposure, long-term, heavy dosages, you create scar tissue and your lungs don't stretch as much. So they're about like this. After 20 years, your lungs are about like this. They're barely moving because you've created so much scar tissue inside of your body. That's what asbestosis is. It's a scarring of the lung tissue created from mass quantities of asbestos cutting the interior of your lungs. This is not something that I would expect to see from a construction worker. This is not something I would expect to see from the general public walking into a building. The folks that had this particular problem either worked in the mining of asbestos or the milling of asbestos, where they took big rocks, threw them in crushers, stood over them 8 hours a day, 5 days a week, no respiratory protection, and breathed that while it snowed in their face, asbestos rocks and minerals. The minerals that we're talking about in size here are roughly 5 microns. A micron is a millionth of a meter. A meter's 39 inches long. So break that into a million times real quick for me. It's humanly impossible. You can't see it. Tiny, tiny fibers that create these kind of problems. The latency period for asbestosis is 20 years. So basically from the time of heavy exposure to the time that you have symptoms, you're around a 20-year period of time. Mass quantities of exposure. Any questions over asbestosis? Okay, we're good there? Let's move on to lung cancer, mesothelioma, and we'll get out of health effects here in a few minutes. Okay. Asbestosis, lung cancer and mesothelioma are basically cancer. The only difference in between the two is lung cancer is interior of the lung, cancer inside the lung itself. Mesothelioma is a cancer of the pleural lining of the lung, the mesothelia are the exterior lining of the lung. In both cases, basically, the fiber is entered into the lung, and then at that point in time, either penetrates the exterior walls of the lung and works itself into the body, or it stays within the lung and the air sac and creates cancer in that particular area. Let's talk about the latency period of lung cancer. Lung cancer has a 30-year latency period. From the time of exposure, typical, now these are periods that are averages, time of exposure to the time you have a symptom, 30 years. Mesothelioma, 40 years. That's a long time, okay? And that comes into play in the regulations here in a minute when we talk about those here shortly. Any questions over the health effects, the 3 diseases associated with asbestos exposure? Yes, sir.
Would you say mesothelioma was?
The latency period?
Yeah, no, was that the outer?
Yes, that's the outer, the mesothelial, the pleural lining of the lung, the exterior lining of the lung. That's where the fiber has made its way through the lung tissue and out into the body cavity. Let's move on and discuss a little bit more about asbestos, about what it might be in. Okay. Asbestos was predominantly used in the United States from around 1920 to about 1980. The heyday for asbestos, a decade right there, the 60s. Okay? Most of the asbestos put in the United States was installed in that decade in 1960. So you get into a building in the 1960s, take it to the bank, it's there somewhere. You get in a house built in the 1960s, it's probably there, residential. Let's talk, it's easier for me to tell you what's not asbestos, suspect asbestos, and what is. There are basically 4 safe building materials never manufactured to contain asbestos, okay? Never manufactured to contain asbestos. Let's see if we can guess what they are. Let's start. Think broad. Broad building materials used every day in construction.
Steel.
Okay. I have my own order. There's no particular order. I just remember them better in my order, so that's number 2. Wood. That's number 1. Two more. One of them is relatively new to the industry, 20, 30 years. Plastics. One more. I put plaster, that's not right. Plastic. Okay, plastic. No, I classify stones and bricks and concrete in masonry. And the only reason why they're not in here, concrete does not contain asbestos, by the way. But back in here and around in here, there were some masonry products that did contain asbestos. Yeah, there were some fire bricks used in boiler applications that contained asbestos. There were a lot of cementatious material, boiler doors. Actually, there were some concrete mixed grouts and things of that nature that contained asbestos back in the 20s and 30s, all the way up into the 40s. So because of that, masonry is not in this group.
What about glass?
That's the last one, glass. Wood, metal, plastic, and glass. Basically, these materials were never manufactured to contain asbestos. Now, there are a lot of other materials that do not contain asbestos. But what I'm looking for are materials that were never manufactured to do that. Now, there's a caveat to this, and it happens to be with wood. And you need to remember this one, it's very important. Although wood was not manufactured to contain asbestos, it has been used to enclose or encase asbestos a lot of times. If I'm in a building and it's a 6th floor building and I'm on the 6th floor at the stairwell, what's that door? What kind of door is that at the stairwell of the 6th floor building?
Fire door.
It's a fire door. Okay? If I'm standing at a fire door, and let's say it's a wood door, that fire door most likely, especially if it's built in the 1960s, what it's going to be is an 1.5 inch thick block of about 65% chrysotile asbestos, a little wiggly one. Around the exterior of that, it's going to have some hardwood to hold on the hardware, hinges and door hardware. And then it's going to have about an 1/8 inch laminate of wood over that to protect it, encase it, and make it decorative. And when that fire burns up to that 1/8 inch laminate of wood, it's going to take it off like that. But it's going to hit that block of asbestos and stop. And it's going to burn up against that block of 65% chrysotile. Okay, so in this case, wood does not manufacture to contain asbestos, but it was used to encase it. So you have to remember the wood, metal, plastic, glass thing when you're dealing with things such as fire doors. Metal also is used to encase as jacket material around insulating materials where anybody in facilities and physical plant would have seen that probably in the past. Plastics and glass do not contain asbestos. There are many other materials that do not contain asbestos, but for the most part, these are your safe ones. Any questions over that? Materials most likely to contain asbestos, especially when you get into the 60s and 70s, textures, joint compounds, ceiling tiles, floor tiles, chalkboards, every kind of mastic and glue used, HVAC mastics, cove-based mastics, What's that?
Curtains.
Some curtains, yes. Curtains contained electrical wiring insulation, a lot of high-intensity lamps, theatrical stage lamps, things of that nature contain asbestos. There are woven asbestos material around those. Many different materials throughout construction have contained asbestos. Doesn't mean every ceiling tile has asbestos in the 1960s. They do not. Doesn't mean every floor tile. Doesn't mean every 9x9 floor tile has asbestos in it. It does not. Doesn't mean every 12x12 does not, because there are many 12x12 floor tiles with asbestos in them. So that's an area where a lot of folks get confused, that they'll think if the material is a 12x12 floor tile, it does not contain asbestos. That is false, very false. Okay, any questions over these timelines at all? Asbestos is used all over our country, all over our world. It's going to be in Walmarts. It's going to be in the church. It's going to be in your kid's school. It's going to be in your home. If your home was built in the 60s or the 70s, I guarantee you I can come find it. And where I'm going to find it, if that's drywall, I'm going to find it right there. I'm going to find it in the joint compound. The vast majority of the joint compounds used in the United States in the 60s and 70s were asbestos containing. Not every one, but a very high quantity of joint compounds. And that's residential and commercial joint compounds. Okay, any questions over that at all? Okay, let's talk a little bit about the rules, the regulations pertaining to asbestos, what you can and cannot do. There are federal and state rules, regulations regarding asbestos containing materials in buildings and what you can and can't do, especially in the state of Texas. In the state of Texas, you cannot perform demolition, renovation, maintenance activities, installation activities, or any other activity that may affect a suspect asbestos-containing material, we'll talk about that in a minute, without first determining whether that material is asbestos-containing and having the proper engineering controls in place. In other words, being trained and licensed to deal with that material. A lot of key words in that statement. Suspect material, disturbing the material, being properly trained and licensed to do so. Let's talk about, break that down real quick and then we'll get you out of here. Suspect asbestos-containing material, as far as the rules are concerned, anything prior to 1980. That's the big date. Don't think there's not asbestos in buildings after 1980. There's plenty of them. I have buildings on my campus after 1980 with asbestos in them. There's not a lot. You don't see as many, but there are some. Mostly what you find is mastics, glues and mastics. So we're talking about buildings prior to 80 being constructed. If that's the case, then let's talk about a public building, what a public building is real quick. It's easier for me to tell you what's not covered than what is covered. Basically, what's not covered in the state of Texas is military installations. They're not covered. Now, there was an agreement, memorandum that was written by President Clinton, which included military installations to fall under the state regulations associated with, or the federal regulations associated with asbestos. Military installations, residential dwellings, 4 units and less. Okay, if it's greater than 4 units, it's covered. If it's apartment complex, it's covered under the rules. Okay, so if you have a public building in the state of Texas, that means the Exxon station down the road is going to get tore down next week. That building falls under the rules. So whoever owns it, doesn't matter who owns it, you tear that building down, you have to have an asbestos survey. You got to inspect, find the material, and remove the material that you're going to disturb before that renovation project or maintenance project. Address that material. It doesn't mean you have to remove it all. If I'm coming in here, and that's not ceiling tile, bad example, if there was a land ceiling tile system in this room, and I'm coming in here and I've got to get in that corner and get to that speaker, I've got to pop one tile. Doesn't mean I have to come in here and remove all the asbestos out of this room before I go pop that tile. That means a trained and licensed person has to go pop that tile. And they've got to move that tile out of the way, clean it up, make sure that that works safe and that area is safe for that maintenance person to go above that ceiling. Keyword, disturb. Okay, you've got to break the material as far as the regulations are concerned. Break the material, get it into the air to where it can be breathed. And that's the issue at hand. That's disturbance, matrix of the material. One key word we'll end on this. One thing to remember, especially in the line of work that you're in, is the word friable. Who knows what friable is? Anybody know the definition? Friable can be that material can be crushed or pulverized by normal hand pressure to release that fiber into the air. Is a ceiling tile friable or non-friable? It's friable. I can break off a corner of it, I can do this, and I can crush it, get it into the air. Floor tile, friable or non-friable? It's non-friable. I can break it, but I cannot crush it and pulverize it with my hand to get that fiber in the air. Now, what can I do to a non-friable material to get it to release asbestos? Grind it, sand it, drill it, some kind of physical device or means of abrading that material. I can use a tool and get a non-friable material to release it. So that doesn't mean a non-friable material is not a problem for us. It just means that if there's floor tile in this room that's asbestos, I can walk on it, I can lay on it, I can do anything I really want to it, but I can't sand it, I can't grind it, I can't drill it without releasing fiber. Ceiling tiles, if they're asbestos containing, can you lift them? Think about that a minute. Now, I've lifted thousands in my years in this business. I have never lifted an asbestos or any ceiling tile that a little bit of white stuff hadn't fell down. Now, if that's an asbestos tile, what's in that little bit of white stuff? That's disturbance. You can't lift them. Joint compound, another good example. I don't want to mark up your wall, but that joint compound in its current condition, friable or non-friable? Non-friable. I cannot crush it or pulverize it with my hand. Now, what I can do is throw a belt sander on it. What happens if I throw a belt sander on it? Katie, bar the door, it's snowing. We all know that. So that would be a disturbance that would take a non-friable material and create a huge problem for you. So think in that mindset, can I disturb that material with my hands? If you can, then most likely it requires a trained and licensed person to do that in the state of Texas. Any questions over that at all?
What about residential?
Residential, if it's less than 4 units, does not fall under the regulations. All these other things still apply, though. The material's still there. It's still a health hazard. To the degree that you're going to expose yourself is probably minimal. Probably not, probably doesn't rise itself to a degree of concern. But you can take up materials out of your house and you can set them on the curb, and the trash service can come by and pick them up, and you're not breaking the rule at all. But you still have an exposure issue you need to give consideration to personally. I don't think it's good practice, but of course many folks do it. Yes?
What's an employer's?
What's that?
What's an employer's responsibility as far as protecting the employees? Survey.
Find it. The very first thing you have to do is find it. And that's what we find, and I've traveled a lot and assisted a lot of different, especially higher education institutions, and the first thing that we find is they do not have good survey data. They don't know where it's at. Until you know where it's at, then it's hard to write policies and procedures that will protect yourself and your employees against it. Once you've identified the location of it, at that point, then put in good general work practices, which include a work permit system, not allowing maintenance personnel to go out into the field and affect a known asbestos-containing material without trained and licensed people being there. So the first key is go find it. And that typically needs to be done, well, that needs to be done in the state of Texas by a licensed inspector and laboratory doing those samples.
What's the employee's responsibility?
To, once educated in regards to the rules, to follow the rules. Basically, the disturbance issue. And that's the one I try to get across to the employees the most, is that you know what your job is, and if you can physically, use that word friable, if you can physically damage that material with your hands or the process you're about to do, unless you know it's not asbestos, then don't do it. You know, if you know it's not asbestos, then proceed, of course. We have folks at our campus that are trained and licensed asbestos folks. We've got 4 of them at UTA that do nothing but asbestos work, 40 hours a week plus. And they follow all our tradesmen around. They follow our carpenters, our plumbers, our electricians. And our electricians and all the trades folks basically have been educated to a point to where they understand that they can't touch that material without asking the question first. Yes, sir.
Once asbestos has been disturbed, how long is it airborne? How long is it still dangerous to be?
There's many theories, many studies were done, but in general, from about your breathing zone, let's say 5-6 feet, person's breathing zone, to the time it hits the ground, could be as much as 24 hours. microscopic fibers, suspend for incredible lengths of time. Can be picked up by natural airflow, moved around a room. Just because the room's clean and looks good doesn't mean it's necessarily clean. Any other questions? I know that many of you, it's time to go home for many of you, and probably myself included. I live a long ways from here. Any other questions? Okay, I want to thank you all again for inviting me to come over this afternoon. Appreciate it.